Dr. Eng here. Welcome to one of my structural mechanics videos. So we're going to be continuing with this stress and strain concept. So I've now got an example which I'm going to proceed with. So let's first read the question. A 25mm square cross-section bar, which has a length of 300mm. It has an axial compressive load, which is a force of 50 kilonewtons. And for this particular problem, we're required to determine the stress and the change in length and that occurs when this compressive load of 50 kilonewtons is applied. The Young modulus is also given for this particular question for the material, and it's 200 giganewton per meter squared. So I've just drawn here this bar. We can see it's got a length of 300 and it's got a cross section by 25 millimeters. So the first step in order to solve this problem is we need to know the cross-sectional area of the bar. So area of the bar. So area of the bar would equal 25 multiplied by 25. That should then give us an answer of 625. Do remember the units are millimeters squared, as stated within the question. So the next step for this particular question is think about what the question's asking you. So determine the stress set up in the bar. Okay, so we know to calculate stress, as in our previous videos, stress equals force over area. So now, if we take a look at the question, have we been given a force? Yes. So we've been given that axial compressive load. That's 50 kilonewtons. So if we put that into the formula, (50 times 10 to the 3). So the area would be the cross-sectional area of the beam, which we calculated earlier, which would be 625. Newtons per millimeter squared, or megapascals, whatever you prefer. So then that should then give us a stress value which the bar is subjected to of 80 meganewton per meter squared. So we also need to calculate the change in length. And in order to do that, we would then need to use the Hooke's law relationship and work out the strain. So we know the strain equals the stress, the axial compressive load, which the beam is subjected to, over the cross-sectional area. So to calculate the strain, we can now do the stress, which we calculated to be 80, divided by the area, which in our case, when it by the Young, it should be the Young modulus, because we're using the Hooke's law relationship. So the Young modulus is given in the question, so that'd be 200 times 10 to the 3. That then should give you an answer of 0.0004. And once you've got the value for the strain, we can then use this relationship. So the strain equals the change in length over original length. Then we take a look on what parameters we have in order for us to rearrange. So we're working out the change in length. We've worked out the strain, and we've also been given the length of 300. So if we just manipulate this, change in length equals strain multiplied by the length given, we can then work out the change in length. Change in length equals 0.004 times the length given, which in our case would be 300 as given in the question. And then that should give us the change in length that the beam that resulted in when subjected to the axial compressive load of 50 kilonewtons. So that should then give us a value of 0.12 millimeters, which the beam has to place. So that's then wraps up this tutorial. Please do like, share, and subscribe if you like my content, and I'll see you for the next one.